Hello students, welcome back to Chemical Kinetics. We were studying how to determine order. This will be our third part of this topic. My friend showed you earlier that there are 4 methods to determine order. We have already seen the integrated method and the isolation method. Let's go for the third one now, that is the initial rate method. But in order to understand the initial rate method, you first need to understand that here in this method, we measure the rate of reaction at the beginning of the reaction, and this method has to be used in combination with the isolation method. So consider this reaction A plus B giving C plus D. Now we all know how to write its rate law expression, that is, rate is equal to K into concentration of A raised to alpha into concentration of B raised to beta. Now here in this case, if we take a large excess of B, then we can say that this expression will become rate is equal to K dash into concentration of A raised to alpha. We also know what is K dash. K dash is nothing but K into concentration of B raised to beta, all constant terms taken together on one side. Now, till here, it's pretty much the same as isolation method. This is now where it is different. What we will do here is, we will take log on both the sides. So this is our expression. R is equal to K dash into concentration of A raised to alpha. When we take log on both the sides, we will get log of R is equal to alpha into log of A plus log of K dash. Of course, I have applied a couple of laws of logarithms. That's how we get this expression. But if you observe closely, alpha is anyway a constant. As A is changing, as the concentration of A is decreasing, the rate is also changing, which means log R and log of concentration of A are the two variables here, which means this equation is similar to y is equal to mx plus c. If you think about it, y is nothing but log of R. And then you have m, which is nothing but alpha. X, which is also a variable, is nothing but log of concentration of A. And C, which is a constant, is nothing but log of K dash. So when we plot a graph, we plot y versus x. We'll do the same thing here. We'll plot log of R versus log of concentration of A. So when you do that, when you plot log of rate versus log of concentration of A, as you plot the initial values of concentration of A and the rate, you will get a straight line with an increasing slope, because slope in this case is positive. Now when you find out the value of the slope, you will get the value of alpha, which is nothing but order with respect to A. Now once you repeat the same procedure, once you isolate A by taking it in excess, you can use the same method, same thing, to evaluate the value of beta. Again, all you have to do is take A in excess, take log, obtain the graph with respect to concentration of B, and you will get beta as the slope. So this is how you can obtain the value of alpha and beta. Now, the advantage of this method is that you can also obtain fractional value of order, because alpha and beta, being the slope, need not be an integer value. This is the initial rate method. In the next module, we will understand the half-time method. Till then, take care.